Just as a quick reminder, in case you're on witness protection, this meeting is being recorded. The recording should be available after the meeting, shortly thereafter, and we'll let everyone know. You'll be able to link to it through the Teams link that you have. It'll also be posted on the KDOT Aviation YouTube channel. Feel free to use that information. It's for the state of Kansas, so feel free to use it in whichever way you would like to use it. We have, just as we always do, a few housekeeping items real quick. Make sure your mic is on mute unless you're ready to speak. And barring any technical difficulties, the recording will be provided. So I already covered all that information. I will move on. We updated the agenda a little bit. U.S. Department of Energy will join to discuss a offering that they have for an energy assessment. So with that, I will stop sharing and we'll jump right into Travis Young. If you're on the call, Travis.
Yeah, I'm here. Let's see if I can share my screen. I put together just a couple slides will allow me to share. There we go. Can everybody see my slides, I hope? Okay, so
Yes, sir.
Just wanted to, like I said, I only prepared a couple of slides just to go through real quick to let everybody know who Evergy Energy Solutions is, what we do, and how we go about it, and then hopefully that'll still leave me enough time for some Q&A and maybe hopefully answer questions you guys really were hoping to hear. So Evergy Energy Solutions is a subsidiary of Evergy, meaning that we report up through Evergy, but we sit outside of the regulated utility. So what we do is we act as a contractor for solar. We work solely in commercial operations. And right now we almost exclusively operate within our service territory. There's nothing that says I can't go outside of it and do an install in, say, a local co-ops area or another state. But right now all we've done is inside of our organization. So with that, who we've done business with and worked with in the past, we've done everything from government locations to sports facilities to large industrials. Nonprofits, we've done a handful of those, but our main focus again has been more the commercial and industrial landscape. Kind of our process overall is when we first meet with a customer, we start doing that remote analysis of the site. We complete like a feasibility study of each location. We run the financial models of what solar would look like at that location and how that would impact. We do a quick review of like policy and regulatory, areas of review. So if there's a county that would have regulations that prohibit us from doing a ground mount, then we want to kind of know that kind of information up front. So we try to run all the traps before we get to the contracting side and the actual build of the solar array. But assuming the analysis comes out positive and the customer's happy with the situation, then we'll start right into our pre-installation contracting, and where we operate as a full EPC. So we're going to fully engineer, we're going to procure all the pieces to the array, and then we're going to go all the way through construction the whole time. So we'll handle, like I said, all the purchasing of the equipment. We're going to handle the install. We're going to run all this, any subcontractors, handle all the permitting, all the way to commissioning, and then we hand that project back over to the customer. Some of a few examples of what we've been doing. Over here in this right side, this is a 20 megawatt ground mount array that's going to be on a tracking single axis tracker, meaning that system is going to follow the sun as it goes. That plant is behind the meter at this large industrial location over here. It is close to being finished. We've probably got about 3 or 4 more months left of construction, but we're pretty excited to bring that one online. We've done that all the way down to, this is a rooftop array that we did at the Kansas City Zoo. So I think that one's about a 22 kW array there on top of the exhibit. We did about 500 kW total at the zoo between multiple locations. So we've got a large breadth of projects that we've completed, from small to the biggest in the area. Whoops, let's see if I can go back. The big thing that everybody wants to talk about and is interested in typically is the incentives, which is obviously what's going to drive decisions on whether solar makes sense at one location or another. The first one that's important is understanding net metering and any limitations that might be there. Understanding that some of your locations might not be in Evergy. In Evergy, we do offer net metering up to 150 kW in Kansas. That's going to allow for your bill to be offset 1-for-1 on any energy produced during that bill period versus energy consumed. If you go larger than that 150 kW, you move to what's called a parallel generation tariff, which just means any generation that you push back to the grid, you're going to get a bill credit for that generation amount instead of that 1-for-1 offset. So when you're doing that financial analysis for specific locations, that's going to be a main topic of conversation. So net metering is a major benefit. Any jurisdictions that don't offer net metering or maybe not as advantageous of a net metering option are definitely lacking in helping solar move forward. The other major benefit is the federal ITC. That's got a baseline of 30% for most projects. In that federal program, there is a incentive for non or tax exempt entities. They call it direct pay. What that allows us to do is, even if you're a nonprofit, you can apply for that same tax credit, and upon getting accepted, they will cut you back a check. It can take up to 18 months after your project is completed before the federal government sends you that check, which is definitely an important note to know. And there's quite a few steps involved to go through that application process when you're making your decision on moving forward with solar. The good news is with that is there's also adders. If you're in energy community, which is any community or neighboring community that has been impacted by coal closures, coal mining closures, those receive another 10% adder. So now you're up to your 40%. And then if you're also in a low income community and your project's under 5 megawatts, you can get another 10% adder to that. So if you are in the right area and hit that trifecta, that's a 50% tax credit that you can receive from the federal government on the project. There is another 10% that you could get in that for using domestic content. But at this time, we're not confident that any of the manufacturers truly meet the requirements of domestic content. And so hopefully in the next 12 months or so, more definition comes out from the government, and we can start pushing that incentive, because that would be another huge help to make these projects actually work out in our jurisdictions. So I flew through that pretty quick. Does anybody have questions? Is there anything that specific somebody would like to talk about?
Travis, you mentioned as far as the incentives for tax exempt entities, the federal government will actually write you a check. And you mentioned, 30, 40, or 50% potentially, depending on the location. So 30, 40, or 50% of the installation costs?
Yes, it's the total project cost. There is things that are excluded in that, things like the fence, the roadways, civil work. It is specific to the generation of electricity. So if the component acts as part of the function of generating the electricity, you'll get that. So typically you're getting like 92, 93% of the total cost that you pay will get that 30% tax credit or 40, whatever the number is.
Gotcha. And is there, how competitive are those grants, or how competitive is that program rather?
So the 30% is not competitive. There is a total limit, but there's not an application process for that. There is a yearly limit for low income communities. So to get your 10%, you apply for that in the year in which your system comes up. There's about a 2-month window where they fill those till they run out of money, and then that one went in. So it's kind of there's just a limit on that 10% value, but the others, the bucket's there, and then it's supposed to be there for the next 10 years till 2032.
Gotcha. And one other question that I had, and certainly people on the call, feel free to jump in, but you obviously, you said you're potentially a subsidiary of Evergy, and you try to stay within Evergy territory. You're not the only, or Evergy is not the only utility. I believe it's the largest utility, but I don't think it's obviously not
Yep.
the only utility. There are several others. Are you aware of other similar programs or similar, commercial applications, or commercial extensions with other utilities?
I am not aware of any in our area. There's some on the East Coast that are doing commercial installs. Duke Energy has a program. And there's a few others that have non-reg programs like myself that are in the solar industry. But I'm not aware of any of the other utilities or co-ops in Kansas that is operating like we are.
Gotcha. And so one other, in Kansas, we have a handful of deregulated utilities, and those are typically municipally owned utilities. And then there are a few regulated, like Evergy. Is there any um, hurdle for one or the other? Is it easier to do a solar project for either the regulated or the deregulated, or unregulated, however you want to take a look at it? Or is it pretty much the same across the board? It doesn't matter.
I would say it is pretty even in that. Some of the municipalities may have more stringent regulations. They may already have reached their limit of what they're allowing to be interconnected within their facility, just from geographical. I think our cap, and Tammy can correct me, is 5% of our load. Once we've hit that, we could potentially stop taking applications for interconnection. Just because of load balance issues and things like that we need to evaluate as we get there. So I know there's a co-op in Missouri that has met that limit, and they are not allowing pushback onto the grid essentially because they've hit that limit. So you can still build your solar, you're not going to get compensated for anything that goes back to the grid, and you're not going to get net metering on your bill. So you're going to reduce your usage, but the economics aren't as helpful.
Thank you. Any other questions for Travis from the group?
Hey, Travis, are you guys doing battery energy storage as well as part of your programs?
So I can sell batteries, and we do have a project where we did install batteries. They're still not quite economical, in my opinion, in our area. Meaning we don't have high enough demand charges and things like that they are commercially feasible, get the payback period that people would like. It's close. It's getting there.
So the demand charges are basically saying it makes more sense just to generate, essentially, is what I'm hearing, because the batteries cost so much, right?
Yeah. So as battery costs comes down, wait, like I said, we're right there. I would say within the next 5 years, I'll be selling batteries with all my solar installs. It's just not quite there yet.
And then can you grid tie, basically put this all behind the meter, like for an airport, that they can, if you add some battery storage, can you basically help them with power reliability, disconnect and keep operating
Absolutely.
with your
Yeah.
assets?
Yeah, if you've got the big enough checkbook that you can put a big enough battery to support your load usage, then you can use it as that backup storage. That's the um, backup generation for any grid failures. Um, the biggest problem I've seen on the few airports that I've done work projects on is trying to find the location to put the panels that's in the same vicinity as the load.
Right.
You've got some rooftops, but then you've got to worry about glare, obviously with the runways and things like that. So the ones that I was working on, they wanted to put the array so far away from the load center. We were going to have to upsize the cable so much we couldn't get the power from A to Z, and the cost to get it there just made the project unfeasible. So that's, to me, probably the biggest challenge with airports is finding the location. You could look right here downtown Kansas City. There's a 25 kW array right on top of the terminal building, I guess, is what I would call it. So it can be right there next to the array. It's just, again, size, how big, how much power do I need? Where am I going to put it?
Thank you.
Battery energy storage from Evergy is going to be part of the next slide here. So we'll discuss that a little bit. Any other questions for Travis while we're on the subject of Evergy's on-site solar?
The only other thing I'll note before I stop talking is if any of your locations have thousands of acres available, and you have a large substation or transmission system there, and would like utility level solar to be placed there, and it's more of a lease situation, so it would be a revenue generator for an airport potentially. If you have that trifecta, again, large tracts of land, got to have infrastructure nearby to make it feasible, but that is a path that you've probably heard, the KCI airport project. What makes that work is the mass amount of land, the infrastructure around it. That gives it that high potential for utility scale, which is different than on-site behind the meter generation, but something to keep in mind.
Well, since you brought that up, I mean, you mentioned thousands of acres. Is it, there are some airports that have some acres that, you know, they would like to be able to lease. What is a feasible amount? I mean, thousands of acres may not be, that isn't used or isn't planned for, may not be available, but is there a smaller tract that may still be beneficial, provided the other components fall online?
Yeah, we'd be talking like hundreds of acres, minimum 7, 8, 900 acres to be able to build a big enough facility that makes sense for utility scale power. 10, 20 acres, 30 acres is not enough for that to be feasible at this time.
Gotcha. Any other questions for Travis? All right, thank you, Travis. Tammy, are you on the call?
I am. Yeah, Travis is going to run the PowerPoint for me. I did some slides as well. I apologize. I was traveling back from Kansas City this afternoon, so I'm coming to you from my car on the at a turnpike exit, but this will be fine. So Travis, if you could share your screen and start with the first slide. But so yeah, Tammy Ray, I've been with Evergy 17 years, and I wear a few different hats within the company. I work a lot with the Travises of the world with regards to interconnection. So I manage the interconnection process for all our residential and commercial customers who are looking to generate a portion of their own power. Evergy currently has about 18,000 of our customers who are self-serving a portion of their power, but I also get the opportunity to be a co-lead on a residential battery storage pilot, and that's what I'm going to tell you about today. So Travis, you can go to the learning objective slide, please. So I'll start with a little background. So the next slide, please. This pilot was approved in Kansas to consist of 100 utility-owned batteries and a Sunbird gateway to be installed behind the meter in our customers' homes. So the pilot provides Evergy full visibility and control of this device, linking this behind the meter distributed energy resource with our grid enterprises systems. We achieve this through that proprietary device, that Sunverge Gateway device that our vendor brings to the pilot. I'll talk a little bit about the technology in a little bit, but this type of integration is very exciting, and this pilot is actually getting a lot of attention from other utilities as a result. But the one of the key learning objectives of this pilot is that it creates, well, from when it creates wins for both the utility and the customer. The utility win is integrating these batteries into Evergy systems so they can be dynamically utilized for demand response, as well as other grid services such as voltage regulation support, while allowing customers who participate in the win with the backup power these batteries provide, along with the bill savings achieved by discharging the battery during peak TOU times. So one of the key requirements to participate in this pilot was the customer has to be willing to go on that time of use rate where they're paying more for power from 4 to 8 than they are, let's say, the other times of the day, and then power from midnight to 6 is really cheap, and that's when we're charging the battery. At the conclusion of the pilot, we'll evaluate peak demand impacts, grid impacts, the effects on participant usage, customer bill impacts, and then overall customer satisfaction. Travis, you can go to the next slide. So the grid is evolving into one that includes customer side flexibility in this form of these distributed energy resources. Across the country, utilities like ours are working to harness that interconnected network and customer assets. This includes batteries, all with the goal to create situational awareness and control of these devices that have the potential to benefit all utility customers through positive grid impacts. The operational knowledge that we'll gain has been a key objective of this pilot, with others being analyzing the charge and discharge strategies, as well as the impacts of this battery when paired with solar. These resources provide the opportunity that empower customers to have a choice in meeting their energy needs. We can lower their energy costs and their own environmental footprint. With this in mind, we do expect the adoption of storage and other DERs in our territory to continue to increase, and that's a key driver of this pilot. Household energy use is transforming, placing utilities at the center of two important trends, right? Decarbonization, and customer affordability. Individual purchases, solar storage system, electric vehicles are all increasing the number of these distributed energy resources. Which can generate power, they can store power, we can flexibly draw energy from the grid. This partial decentralization of production and storage is really challenging that historical utility unidirectional power flow that utilities are used to. So if unmanaged, the resources actually could complicate utility efforts to balance customer needs and desires. But if we can successfully engage customers, those DER devices have the potential to help us meet peak demand with clean energy, as we primarily charge these batteries overnight when we have an abundance of wind energy, while providing other areas of support to the grid. So Travis, you can go to the next slide. So we see this pilot really having the potential to bring several benefits to all Kansas customers. And I should say too, for this particular pilot, it is residential only. We're using an LG Home 8 battery that's the sizes of 15 kWh. So this battery for this particular pilot really isn't applicable to commercial applications. So our 100 batteries are on residential accounts. But the immediate benefit to participating customers is the backup power and the resiliency. And then again, the bill savings through that TOU arbitrage. Power is cheap and wind power is abundant, and then we're discharging it primarily from 4 to 8, but then also throughout the day to make a nice smooth load pattern and offset those high peaks. So we're saving bill savings through TOU arbitrage, but we're also providing customers the opportunity to have that greener footprint. We believe all customers can benefit in the long run from the outcomes that are not so immediate. The integration into our grid enterprise system to these resources really does allow us to aggregate those to deliver a range of grid services, the peak load shaving, voltage regulation, and bring relief to congested grid infrastructure. I'm sure this is not a complete or comprehensive list, but it's certainly where our intentions are. Travis, you go to the next slide. So this is a 2-year pilot that will conclude at the end of 2026. At this point in the pilot, for Kansas, we have about 10 batteries installed and about 30 more scheduled before the middle of December. We have 3 local companies that are Kansas-based companies that are contracted to do the installs with us. And we're primarily installing, we have one company in what we refer to as the South, but he's out of Augusta. So the South area, we have a company that's installing batteries in our Kansas metro territory and another company that's installing some like in the Topeka Lawrence area. But ultimately at the end of the pilot, we will take a few months to evaluate all the data, and is our obligation in this Q2 of 2027, we submit a final report to our regulators on the outcomes. So you can go to the next slide. I'm going to stop for a minute before I talk a little bit about the technology that we're using and see if there's any questions before we go on. If not, we'll go to the next slide. Oh, sorry.
One thing.
You have something?
Yeah, sorry, Tammy. So residential, obviously not for commercial application, but Travis spoke a little bit, or previously about the potential for commercial application within the coming years.
Yeah.
People are looking for, potential partnerships, or, we're interested in looking at these commercial applications. So if you're looking at, a similar pilot, we'd love to be a
we
potential.
Definitely are. Yeah. And so one of the drivers for our commercial pilot is a business demand response offer, right? Capacity is king in the world right now. We are a utility that is seeing growth, load growth demand greater than we've seen in the last 30 years. And 10 years ago, no one would have ever anticipated those super users, those data centers that are coming along. And so load management is becoming key. And so I do see us in the future partnering with commercial customers through whether that's storage or other things to help them participate in our demand response program. So again, this was a very small first step, toe in the water, but we are definitely, I was at a peak load management conference last week and met with companies just for that purpose, to look at those commercial applications, to see how that would be the next phase of this. So I'll talk a little bit just about the technology. So again, this battery energy storage pilot, one of the key features is that centralized demand response management system, or that DERMS platform, that allows the utility to see the state of charge, manage the state of charge, and see that in relation to what's happening on the grid at that one time. The way this is different than other battery pilots that you may have heard of, like Rocky Mountain Power, for example, has a large battery pilot that they partnered with Sonnen batteries and inverters to use. And it works fine as a VPP in that Sonic, they can push a button and send a signal and discharge batteries and reduce load in that area. But that information is not part of a grid enterprise systems. The Sonnens of the world, the Teslas of the world, the Enphases of the world, they really work hard to keep that data and that control in-house. And we were just really looking to bring that more within the utility purview, as opposed to having to work through that third-party vendor. So that's one of the unique differences to this pilot, as opposed to others you may have heard about. But the batteries utilized, we do orchestrate a variety of charge and discharge scenarios that are really there to optimize. About half the customers have solar, half of them do not, as we test both. So we want to optimize their solar. We want to maximize bill savings by offsetting that time of use rate. The pilot does include a smart home energy control system that is programmed, that we use to program all those rates into It is an AI driven, it does use an AI driven algorithm to collect real time data and manage charge and discharge. So much like if you think about a Nest thermostat that kind of learns your patterns over a few days and then can respond automatically, this battery sort of does the same thing. It'll learn the energy use and energy needs of a home within a few days, and it may only charge the 60% overnight because it knows your energy use is usually pretty low and I don't need much. And again, it will discharge when the air conditioner comes on and it sees a large spike, it'll discharge to kind of smooth that spike out, as that's one of the drivers, is we're just trying to create a better load profile. And then this pilot does give us that real-time visibility into battery performance and state of charge, creating that dynamic grid asset that you don't see in a lot of other pilots. Next slide. And this slide just really shows that it is a win-win for all, using that AI driven structure that is at the heart of that. We can configure the sites, we can manage customer preferences, we can program it based on rate structure, the amount of reserved power. For example, if I have a customer who has said to me, my top priority is bill savings, then I'll only reserve about 25% of the capacity in that power in that battery, so that the bulk of it's offsetting that 4 to 8. But if they're really looking for backup power, we'll protect a little more of it. And then again, those charging and discharging strategies. One of the key components, on the next slide, please, Travis. So utilizing that DERMS platform and that home energy management controller that gives us that end-to-end visibility and that awareness that we're looking for. The key, one of the areas that we're working on now is bringing in weather data. So if the weather shows that there might be bad weather coming later tonight, what I want that system to automatically do is either charge the battery during a shoulder peak or an off-peak time, charge it a little more than usual, or maybe discharge less during 4 to 8, so that if that storm's moving in tonight, that we have something protected in the event of an outage, that there's plenty of power there. That's an example of something we can't do today, but 6 to 9 months from now, we should have fully integrated that. So much like we call on, some of you may, if you're Evergy customers, you may have participated at some point in a thermostat program, which is a demand response program. We'll have hot days in the summer where we may cycle your air conditioner through that thermostat to help reduce peak. That same system that sends out a signal to thermostats, we want that same system to work for batteries the same way, so that we ultimately have a more complex VPP out there at our disposal. So that was all I had. If there's happy to take any questions. If there's any, if not, I'll turn it back over.
Any questions for Tammy from the group? Thank you, Tammy. Appreciate the information. And like I said, keep us posted about the commercial applications. Especially if you want to do any research or have a partner in that. Definitely interested in exploring that.
I love that. Yes, thank you.
Thank you, Tammy. Up next, Scott from National Renewable Energy Laboratory. Hi, Scott.
Hello. Tammy and Travis, it's great to see what you all are doing, and you're using words that are they're close to a lot of people I work with. So thank you. I don't go too many places where people start talking about DERMS too quickly, but it's a common phrase at our place. So it's nice to hear. Let me get sharing going. So my name is Scott Carey. I basically work on the aviation components at the National Renewable Energy Laboratory. And let me get this up and in place. And so let's go from here. So when we talk about aviation, so NREL, just real quickly, we're one of 17 national labs, but our primary role is renewable energy and sustainable transportation and energy efficiency. And so when you start talking about putting all these energy assets distributed out across the nation, that's a solar system, that's a battery system, that's smaller components at different places around the grid. Those are all items that are being researched and then ideally help industry move forward in terms of solutions that can be deployed. So we're about, I just looked at what we're now, just go left on I-70 for about 8 hours and you'll end up at our main campus in Golden, Colorado, is where the majority of our staff are. Around 4,000 people. And we do a combination of, we're a DOE national laboratory, but we do about 20% of our work with external partners, utilities, oil and gas companies, airports. We work on work for the FAA and others. And really what we're trying to do is, there are a lot of amazing ideas that say might be at the university level or basic research. We're trying to help bridge that gap from a great idea until items can be commercialized. And so that's really where we're slotting in on aviation as an example. For perspective, heavy trucking, there's roughly 13.1 billion tons moved every year across the transportation system. Maritime, we use these numbers for maritime and aviation because each has its own role. So if we think of maritime, 80% of the cargo around the world moves by ship. And 30% of that movement around the world is energy, is petroleum, natural gas, coal, other energy carriers moving between locations. Within aviation, we think about that as there's roughly 4.5 billion passengers around the world in 2019. It's expected to double in the next 20 years, just out of the rate of growth. And roughly 35% of the cargo by value. So it's high value, low weight items are traveling by aviation. Think cell phones, think the perishable goods, those types of items. So as you look through the different discussions, we get into, NREL has been engaged in this for, since the late 1970s, looking at different opportunities to generate energy here in the US. And then how is that being used? And a portion of that has to do with transportation decarbonization. What ends up occurring is, depending on where you're at in that system, you may have different options. And now for at least our group, one of the main things we look at is say, okay, now how do we start with a clean electron and move passengers or goods? And so when we start to look at the technologies and where they currently exist, the smaller the vehicle, the more likely, just like an electrical battery might work, because you have extremely high efficiency in electric motors. But the energy density of the batteries is lower, but it's acceptable at this point, on light duty vehicles. When you go to, say, heavy duty trucks, then you start to get a little more complex. What am I using it for? What's the distance? Is it going to be a biodiesel? Is it going to be a hydrogen at some point? Or, is it a short route that makes sense that, hey, we can do it with batteries? The key thing we look at is what's the most efficient way to turn a energy carrier into movement. And the fewer number of phase changes or changes in how the chemicals are set up increase the efficiency. So if I have to take an electron and I can put it straight into a 98% efficient motor, that's probably the most efficient way to do it. But that may not be the way that you need to operate in terms of if you want to have a Class 8 truck refueling in 5 minutes, because you can't move enough electrons that quickly. When we get to aviation, because of how energy dense petroleum is, it's petroleum lookalikes, it's Jet A. And there's been a long, going back to, I think since at least 2006 is when I believe CAFE was formed, to look at using alternative fuels as jet fuel replacement. So when we talk about sustainable aviation fuels, it is a Jet A equivalent drop-in fuel, with a few exceptions in terms of trying to move towards dealing with some of the unique characteristics that are within a current jet fuel. This component called aromatics, and how those interact with existing engines. So Internationally, there's the goal both at ICAO and IATA, and also within the federal government of the United States, looking to decarbonize by 2050 the industry. Within the US, that's turned into the SAF Grand Challenge recently. It's been moving along for 20 plus years. Just recently, it's like, okay, we have enough pathways and ways to make these products that we're pushing that forward. And so now the goal is 3 billion gallons by 2030. Possible, but it's a stretch. You know, it's an extremely fast scaling occurring, and with the intent of 35 billion gallons by 2050. Okay, so replace all the petroleum in aviation by 2050 with alternative biofuels. So as you start to think through this system, we get into this discussion of how are we looking at energy efficiency? How are we looking at transportation of energy carriers? What are characteristics of the system that may change depending on how we kind of put this together? So as an example, if you use an electric motor to turn a propeller, your noise profile changes. If you use an electric motor to turn a propeller, you may be able to use smaller motors and come up with a different way of operating or a different form than what basically in the 1950s everyone came to as a tube and wing. Primarily, part of that has to do with how the engines are set on the wings and where the fuel can be carried in the wings, as an example. And you start to chase through those systems. At the same time, if you start to think about these potential new energy carriers or methods, you get into the discussion of we have a very successful and well-capitalized petroleum supply chain system around the nation and around the world. So any of these new technologies is how does that fit in? And similarly on electrification, just like you heard just a minute ago, is okay, there's mass scale occurring. How do we keep up? Real quickly, just like we talked about with the different size of vehicles, there are different opportunities occurring within aviation. Depending on the size of the vehicle, there's projections. This is from the ATAG Waypoint 2050 study, basically saying here's where they think the technology is going to be on these different efforts. The aircraft that are shown, the first two on the top have flown and are moving forward. Beta, who's the second one down, their first production aircraft of their CTOL aircraft flew its first flight last week. So, and the one above is a fixed wing aircraft with 9 small propellers that can take off in 100 to 300 feet, called Electra Aero. Just two examples here. I mean, there are many more. So the way the system currently works is your airports, they traditionally have had your fuel supplier, have to interact with the fuel suppliers, utilities, the airlines, and then your state and local agencies, because they knew that petroleum system was there to back up what they need and to make things work. But what we're seeing is this is transitioning. It gets really messy, and so how do you plan? How do you think through those different solutions? As everyone is trying to ask for more power across these systems. We kind of look at this as NREL is not aerospace, but what we do is we think about the system as the energy components that run through aviation. And so the fuels, the energy carriers, the airport and the airspace that goes with it. And then how does that tie into the aircraft and the components that may go through that? And there's trade-offs in that system. What's your power reliability you need? Resilience posture, is it this discussion that was just had about whether it's cost effective to include batteries in your system. If you're a 24/7 critical facility, is your diesel generator what you want? If you can do demand response, as an example, with with your utility. Is that something you want to consider as part of your system? And you can make your generators last longer. Those are the type of discussions we get into in terms of kind of the trade-offs that occur. And then what does your community want? We're starting to see more lawsuits popping up around leaded gasoline for general aviation, as an example. And the unleaded is moving. It is expensive. Each aircraft of the legacy aircraft have to get their own special type certification to be able to fly, from what we're hearing. And we'd love to get, if there's others on the phone that have better inputs, we'd love to get more information there. So 4 different energy carriers we currently keep track of. SAF is your traditional biofuels. That's your biodiesel. That's your ethanol to jet type of pathways. E-fuels is clean hydrogen. Turn that into, use some type of CO2 upgrading source, liquefy and blend it, and then turn it into a jet fuel lookalike. E-fuels, the big thing is the technology is there. It's just expensive. It's more expensive than SAF, which currently cannot compete directly with petroleum just on a straight cost basis. Hydrogen, the big place with hydrogen right now is the infrastructure, and then scaling for cryogenic, so extremely cold cryogenic hydrogen for aircraft. There is still need around reshaping the aircraft, because the way hydrogen wants to be stored, it doesn't want to be stored in wings. It likes to be stored in spheres, in terms of to keep it cold and insulated. And then the electrical system as well, as you move through that. Real quickly, we look at airports as small cities, and the question is, which of the assets do you need to look at, and how do you want to put those together for your specific mission? Whether it's local medevac, whether it's emergency response, if it's typical GA operations, realistically, it's what parts and pieces come together around those systems to help make sure you can do what you need to do every day, which is move passengers and goods. So within the aircraft, there's typically a layer of components as well that become important. And so, just as an example, helping the FAA right now with some of their, we're doing analysis to help them develop policy for hydrogen aircraft. One of the questions is, well, how do you know if you have a leak, and how big of a leak is something you have to worry about? If you talk to the space industry, you're going to get a different answer than if you talk to our labs, because in terms of how we look at those risks, where does the FAA want to come into those situations? So there's like a whole safety and sensing program just on keeping track of leaks and understanding how all those systems might work. In this, I just put a short list of some of the groups that we're aware of working on within aviation. And, just in the last week, Department of Energy has put out 2 new publications around SAF deployment. If that's of interest, can share those as well. Looking at saying, here's kind of the status of where we're at, and here's where we're going in terms of those programs. So with that, I just wanted to we really appreciate the time. And if you have any questions, we're always available to share information and pass that on as we see it. And we're always looking for input as well. So thank you.
Thank you, Scott. Thank you, Carrie, rather. Any questions for Mr. Scott Carey, rather? Sorry about that.
It's good. It's good.
2 first names.
Yeah, there's actually 3. There's the other one too. So I get all kinds of stuff. So.
Excuse me while I remove my foot from my mouth there. Any other questions?
You're good, Ray.
First of all, if anyone on the call is interested in a SAF discussion, we are likely going to ask NREL to give us some feedback and information about SAF, but we'll get that under a different group. So if you're interested in learning more about sustainable aviation fuel and how it could potentially benefit your communities, or how you can potentially work that into your community, please feel free to reach out to me. It's obviously a little bit of a different discussion than this general scope of the emerging aviation technology. And we do have some stakeholders that are interested in that discussion. So we'll reach back out. Any questions? All right. With that said, is Ben on the call? Mr. Campbell?
Yeah, I am. Hey, Ray. How are you doing?
Fantastic. Thank you, Ben. Ben with the, actually, I'll let you do the introductions and feel free to jump on. Thank you very much, sir.
Yeah, absolutely. Thanks so much. And I appreciate the time here today. Um, my name is Ben Campbell. I'm a principal research engineer at the University of Illinois, Chicago. And I'm also the assistant director of the On-Site Energy Technical Assistance Partnership that's funded by the U.S. Department of Energy. And I manage the central region of the On-Site Energy Technical Assistance Partnership. So today I'm just going to highlight some of the resources that are available both through the Technical Assistance Partnership and then also some of the federal incentives that are available. And Travis touched on the ITCs during his presentation, so I'll try not to spend too much time on that. But just the topics that I'm going to cover are the On-Site Energy Technical Assistance Partnership, the technical resources that we can provide through the Technical Assistance Partnership, and then go over the federal investment tax credit. So there are 10 regional centers that do on-site energy technical assistance. The central region being the four green states right in the middle of the United States there. The three offerings that we provide as part of the Technical Assistance Partnership is no-cost technical assistance to any interested end user. We also do end user engagement, so attending events like this, and we were at the Kansas Department of Economic conference last week. And then we also do stakeholder engagement, so we'll meet with strategic stakeholders like utilities and policymakers to identify barriers that are preventing on-site energy adoption. So again, this is the 10 regional centers and the directors of each of the regional centers. So if you do want to work with one of the TAPs, just reach out to the contact that's listed on the slide deck. And I believe that this slide deck will be provided after this presentation. So yeah, happy to send my slides over to anybody that's interested. So the on-site energy program is designed to help any end users consider on-site energy within their facility. So behind the meter distributed energy resources. We can model a number of technologies as well as integrated technologies working together for you. And so we can look at cogeneration systems or combined heat and power systems, district thermal energy systems, fuel cell technologies, ground source heat pumps and industrial heat pumps, and as well as photovoltaic systems, solar thermal, thermal energy storage, and wind and battery storage technologies. So why is on-site energy important? The Department of Energy is funding this project as part of the industrial decarbonization roadmap. Of that decarbonization roadmap, they're looking at 4 pillars to decarbonize: energy efficiency, renewable fuels, on-site distributed energy generation, and then finally carbon capture, utilization, and storage. So there are a lot of benefits from on-site energy technologies. The main benefits that most end users are interested in are the cost savings and sustainability impacts, but there's also energy independence and energy resiliency as a benefit, preventing your facility from going offline. So to go over the on-site energy tap resources, how to work with the tap, you just need to reach out to me or my director, Cliff Hefke. So you contact your regional tap, and then we'll set up a meeting with you to discuss site characteristics, goals, and objectives, how your airport facility uses thermal energy and electrical energy on site, how much your demand fluctuates on site, to identify technologies that would work best for you. We'll collect some site data. Typically, the minimum data that we'll collect is 12 months of natural gas and electricity bills. It's also really helpful if we can get interval demand data for some of our technologies to model. Then the on-site energy tap will do a techno-economic analysis and perform screenings for multi-technology options within your facilities and provide simple payback incentives that are available and the savings that you can expect from installing a variety of on-site energy technologies. Then finally, we'll set up a meeting and we'll review the results with you and talk about next steps that the Technical Assistance Partnership can provide. We're really there to sit on the end user side of these negotiations and provide non-biased third-party information for a lot of these technologies. So when we look at site attributes, we really want to focus on what technologies are going to work best for what sites. And so if you have high electric rates, renewable energy systems, as well as cogeneration systems can be a good application, but those high electricity costs make heat pumps less favorable. If you have high demand charges, battery energy storage systems can help with demand curtailment, as well as combined heat and power systems. As we have natural gas rates start to go up, that's when heat pumps become a more favorable technology. And then, what's the land conditions, the open space conditions that we have on site? Do we have available roof space for photovoltaics, land space for wind or photovoltaics? And then what are the heating loads and how do they compare to the electric loads on site? So when we see concurrent heating and electricity loads, that's when wind turbine systems and cogeneration systems can be really beneficial in driving savings at a facility. So just an example of what the results look like from our techno-economic analysis. In this analysis, we've modeled 3 on-site energy systems, a photovoltaic array, a wind turbine, and a cogeneration system. And then we also will model these technologies working together to try and optimize the economics for your facility. So in this case, we combined a 700 kilowatt photovoltaic array with a 300 kilowatt cogeneration system. I also just want to highlight, we'll generate a simple payback as part of our analysis, but we'll also look at the emissions impacts based on where you are regionally on the grid. We'll use your regional grid emissions factors. So then in terms of federal grants that are available, and I apologize, it doesn't look like this slide format looks very nice. There is the Inflation Reduction Act federal investment tax credit that Travis mentioned. As long as your on-site energy project meets prevailing wage and apprenticeship requirements, you're eligible for up to 30% of the total install cost for your on-site energy system. And as mentioned, there's an additional bonus for energy communities. So you can get another 10% of the total installation cost. Looking at the Kansas map, for energy communities, it does seem like it's mostly on the east side of the state. So if you have a facility that's near the east side, it may be worth looking up and seeing if you're eligible for that energy community bonus. And then there's a domestic content bonus. So you can get an additional 10% federal investment tax credit if the system is manufactured in the United States. Legally, I think the definition is that 60% of the steel that goes into the project, including rebar that's going into the concrete that would be supporting the project, needs to be produced domestically. So it needs to be U.S. steel. So what does that mean? So prior to the Inflation Reduction Act, there was a federal investment tax credit of 10%. for any renewable energy projects, so solar and wind projects, after the Inflation Reduction Act passed, and as long as you meet the requirements for those additional bonus credits, you can get up to 50% of the total installation cost reimbursed by the IRS. So it would come from your tax filings, and as Travis mentioned, for nonprofits, they are paid out directly in the form of a check from the IRS. So just to summarize, the On-Site Energy Technical Assistance Partnership started this year. We were formerly the Combined Heat and Power Technical Assistance Partnership. The Department of Energy decided to open up on-site energy technologies to all available options for industry to decarbonize. All of the technologies that we work with and model are mature and market ready, so we're not doing any emerging or high-risk technologies that we're modeling for any of our industrial or other end-user partners. And the Central On-Site Energy Technical Assistance Partnership is available to provide no-cost technical assistance across all of the technologies that I mentioned today. We will highlight any utility incentives that are available, as well as federal incentives like the Federal Investment Tax Credit and the USDA REAP grant. We are also a qualified assessor for the Department of Energy's Industrial Assessment Center Implementation Grant, which is up to $300,000 with a 50% cost share requirement. But that's only for manufacturing facilities that have an NAICS code of starting with a 3. So it's more towards manufacturers for that incentive, but we can certainly check your eligibility for any of those incentives as part of the program. So if that is of interest, here's my contact information. I encourage you to reach out to me. We're happy to do technical assistance for any interested end user. This is a federal government program, and so I usually tell people, you know, it's not no cost technical assistance. You've already paid for it, and so you might as well get the benefit of it. And I'd like to say thanks again, Ray, for giving me the opportunity to speak here today. And I'm happy to answer any questions that anybody might have.
Thank you, Ben. I really appreciate it. No cost or prepaid through federal tax dollars. I appreciate that just the same. I think there's a lot of value in that service, absolutely, for our communities. And I would love to, put that information out there. I hope we don't inundate the office with, the calls. I would hope that every single one of our communities reaches out, because they need to understand what their energy loads are, and what their needs are, not only for immediate, but their how they can take care of their immediate need. And if they're in a good place, with energy resilience and, having on-site solar is a prime example. They have on-site solar, they have a battery system that serves them immediately, but it also puts them in a great position to be able to take advantage of emerging trends in aviation that are all going to be electrified or hybrid technologies. So getting them in a great place now, getting them great return on investment now, and especially if there are grant dollars available to do that, that's an absolute win in my book. So thank you for offering that. Any questions for Ben? Perfect. Thank you again, Ben. Our next meeting is tentatively scheduled for December the 19th, 3 to 4 p.m. If we don't have subject matter to discuss, we'll likely just give everybody that meeting off, since it's December and everybody's trying to get prepared before the holiday. If you have any suggestions for future meeting topics, or if you want to discuss your own efforts within emerging aviation technology, or you want to outline where you think the state should go, please reach out to me, or Commerce, or any of the stakeholders on here. We need to kind of have valuable, meaningful meetings, but I don't want to hold a meeting for the sake of holding a meeting. So let me know what you guys have in mind for the future. Thank you for your time. Sorry we went a little bit over. I didn't do the math very well as far as getting the meeting scheduled, but we've had some very meaningful conversations today. If there's nothing else, look for the meeting recording here in a few days, and I appreciate everyone's time.
Thanks, everyone. Thanks, Ray.
Thank you.